Assalamualaikum, ma'am.
Walaikum Assalam. How are you?
Alhamdulillah, I'm fine. How are you?
I'm good. How's your result? Board result?
It was okay. I got 92, like overall.
Overall, 92%.
Yeah.
That's good. It's good. Many congratulations.
Thank you, ma'am.
In chemistry, what's your marks?
What, ma'am?
Chemistry? Chemistry में कितने आए यहाँ पे आपको?
I still haven't gotten the marks. We'll get them on Sunday.
Okay. Okay, let's wait for Fatima, then we will start the class. Today, I'm going to start your new chapter, Atomic Structure.
We started chapter 3 in school.
Okay, no problem. After that, we will start the periodicity.
Okay, ma'am.
Yeah.
Ma'am, in the last class you had given this question in a reaction A is equal to A plus B2 is equal to AB2. Identify the limiting reagent following.
Yeah.
Can you explain that question again?
Okay, no problem. I will explain. Okay, is my screen visible?
Yes, ma'am.
Okay, so the question was, it was from the NCRT, I think. Let me see the question. Okay, yeah. So the question was, you have to determine the limiting reagent, right? So the reaction was A plus B2 and the product was AB2, right? And you have to identify the limiting reagent. So the first question was 300 atoms of A plus 200 molecules of B, right? So this was the question. And what is the limiting reagent? We know that limiting reagent is the reagent which get consumed during a reaction, right? Fully consumed during a reaction, which cause the reaction to stop, right? Which is present in a limit amount. That is the limiting reagent, right? So here from the equation, yeah, जब भी आपका stoichiometric equations हो, just refer the balanced chemical reaction, right? Right. So this is a chemical reaction. So here you can see that A plus B2, just a second, this is a reaction. So here what's happening? Okay, now you can see there's something which now you can see. So from the equation, you can see that A plus B2 is equal to AB2, right? So here you can see 1. What is the coefficient of A? 1. Coefficient of B is also 1. And here coefficient is 1, right? So we can say that one atoms of A. You can see here only A atom is there, but B ke kya hai? B ke molecules hai, B2, which is a molecule over here, right? So we can say that one atom of A reacts with one molecule of B. One molecule of B. Can we say that from the equation? One atom of A is reacting with one molecule of B because B2 is a molecule, right? So we can say one atom of A, it combines with one molecule of B to give AB2, right? One molecule of AB2. This is a compound AB2. So this is a relation between A and B. One atom of A reacts with one molecule of B. So here from the question you can see 300 atoms of A is reacting with 200 molecules of B, right? तो वन एटम ऑफ ए रिएक्ट कर रहा है वन मॉलिक्यूल ऑफ बी के साथ, तो कैन वी से 200 मॉलिक्यूल्स 200 atoms of A will react with 200 molecules of B? Can I say that, Aisha? Hmm?
Yeah.
Yeah, because from the question, one atom of A is
Oh,
reacting
yeah.
with one
Yeah, yeah,
molecule,
yeah.
right? So 200 atom, so 200 atom will react with 200 molecules, means 100 atoms जो A के हैं, 100 atoms A के, ये excess में है. 100 atoms of A is in excess amount. This is in excess amount, but this is consumed fully. This is fully
Yeah.
consumed, right? So what is the definition of limiting reagent? The limiting reagent is fully consumed in a reaction, and that it causes the reaction to stop simply. So due to this, ये fully 200 molecules of B, they combine with 200 atoms of A, and reaction आपका और आपका प्रोडक्ट AB2 बन जाएगा, राइट? और ये जो आपका A जो होगा, A, this is an excess reagent, right? 100 atoms जो A के हैं वो एक्स्ट्रा है, 100 atoms A के excess में है, right? Is in excess.
Yeah,
But
ma'am.
in question they have asked the limiting reagent, so B is the limiting reagent, right? So that's how we
Yeah.
do that type of question. I hope you understand now.
Yes, ma'am, I did. Thank you.
Okay. Okay. After the class, do all the parts of this question. Okay.
Yeah, ma'am. Okay.
Written or not? Written? Can I rub this?
Yeah, ma'am, you can. I wrote.
Okay. Okay. Fatma has joined or not? Fatma is not going to join? Okay, just let me check if she is joining or not, then I can start the class. Any other doubts, Aisha?
No, ma'am, that's it.
Okay, just wait 2 more minutes for Fatima, then we will start. Sorry, I was not available last 3 days because my grandma expires on Monday. Yeah, that's why I won't available.
Inna lillah. May Allah grant her Jannatul Firdaus. Ameen.
Ameen. Okay, just tell me this. जब तक वो join नहीं कर रही, we will do some question. So same question is A plus B2. It will give you AB2, right? This is the reaction, and the part is 100 atoms of A plus 100 molecules of B. Now tell me, you have to tell me the limiting reagent. Which one is the limiting reagent? Second part, when 2 mole of A, when it is combining with 3 mole of B. Okay, in both the parts, tell me the limiting reagent.
Ma'am, the first one is a complete reaction. There is no limiting or excess reagent.
Yeah, very good.
Because one
Right.
atom of A reacts with one molecule of B, then 100 atoms of A react with 100 molecules of B.
Yeah, very good. So it's a stoichiometric mixture. Means there is a no limiting reagent. Okay. No limiting
And
reagent.
this second one, A is the limiting reagent because 2 moles of A react with 2 moles of B.
Yes, is a limiting reagent. Very good. Now you understand that type of
Is
concepts.
yeah. Now I got it.
Okay. I think we should start the chapter. She's not joining. Okay, Aisha. So you have read this chapter in class 9th, remember? In which you have learned what is atom, the Dalton's atomic theory, the structure of atom, discovery of subatomic particles, atomic models like plum pudding model, Rutherford model, etc. Remember those models?
Yeah.
Yeah, so that's the continuation of this chapter. हमने 9th में पढ़ा था, अब हम फिर 11th में पढ़ने जा रहे हैं, बट कुछ टॉपिक्स होंगे वो एड अप होंगे. Okay. So let's start from the basics first. So what is atom? Question is, what is atom? So atom is nothing, it is a fundamental unit of matter, right? What is atom? It is a basic or fundamental unit of matter, right? Now
Yeah.
see, a structure we have just studied in the earlier class. This is this type of a structure is of atom. So this is the atom, atomic structure, and here in the center, nucleus is present, right? Nucleus is present, and what is in the nucleus? Neutron plus proton. Neutron plus proton. And we know that proton is positively charged particles, right? And here on the orbitals, electrons move. There's an electron cloud around the nucleus. Around the nucleus, this is an electron cloud over here. Okay, so this is the structure of atom. Okay. And what is the charge of electron? Electron is negatively charged body, right? Negatively charged, and proton is positively charged. Positively charged. And what about neutron? Positive or negative?
Yes, it's neutral.
Yeah, it's neutral. Good. Okay. So see, at first, John Dalton gave the atomic theory. John Dalton gave the atomic theory in 1808, right? In 1808, John Dalton he gave the atomic theory. और मैंने आपको लास्ट प्रीवियस क्लास में भी जॉन डाल्टन की atomic theory बताई है. I just
Yeah,
taught the postulates, what are the limitations of Dalton's theory, each and every. Do you remember what
yeah.
is said in his theory? What is said?
I don't remember all the postulates properly.
Okay,
But
just tell me one or two postulates.
in a reaction, the mass can neither be created nor destroyed.
Yeah.
The law of conservation of mass. And then atom is the smallest particle of a matter.
Yeah, which is indivisible. He used
Which is indivisible.
Yeah, right. So Dalton's gave this theory, and in this theory, he gave 5 postulates. Right? He gave 5 postulates in which he said atom is the smallest, dense, and hard indivisible particle. Right? Further, इन्होंने जो थ्योरी दी थी फर्दर जब इलेक्ट्रॉन की डिस्कवरी हुई तो ये जॉन डाल्टन की थ्योरी जो होंगे ये रॉन्ग प्रूव हो गई. राइट? बिकॉज ही सेड दैट एटम्स इज इनडिविजिबल. बट जब इलेक्ट्रॉन की डिस्कवरी हुई बाय जॉन जे थॉमसन, राइट, तो इसकी डिस्कवरी, इसके जो ये थे, जो भी पोस्टुलेट्स थे, वो रॉन्ग प्रूव हुए. राइट? सो इन 1808 John Dalton gave his theory, which is atomic theory. After that, Thomson in 1897, electron discovery was J.J. Thomson. He gave a Thomson model, and by this, electron was discovered. Right? J.J. Thomson. J.J. Thomson. Okay. In 1911, Rutherford performed an experiment which is known as Rutherford gold foil experiment. Rutherford gold foil experiment. Right? इससे प्रोटॉन की डिस्कवरी हुई. Right? Further, in 1912, Bohr's model of atom was given. Bohr's model of atom. Right? But at that time, this model was very, very popular. Right? At that time, जब ये model दिया, Bohr model of atom, तो at that time ये बहुत ही popular हुआ. But after some time ये भी fail हो गया. Now we read about the quantum mechanical model. Quantum mechanical model of atom. Right? So see, this John Dalton atomic theory, right? Atomic theory of John Dalton, J.J. Thomson, which discovery of electron, which was done by cathode ray experiment. Cathode ray experiment. We will discuss it in detail. What was cathode ray experiment? Then after that, gold foil experiment in 1911, after Bohr model of atom. But see, in the 9th standard, you just get aware of these 3. But in this chapter, in class 11, we will mainly focus on these 2: Bohr model of atom and quantum mechanical model of atomic structure or atom, you can say.
We had Bohr model as well, but like that was in brief.
Yeah, Bohr model, but we will focus on these 2 in this chapter. Okay.
Oh, so it's more like a history of
Yeah,
atom.
it's just like a history of atom. Atoms कैसे आए, जैसे आए और वो wrong prove होती गई. फिर further scientists उस पर discovery किया उन्होंने, फिर वो भी wrong prove हुई. Then इसी तरह से सारे scientists different atomic models हमारे पास आए और different. अब last जो हमारा latest जो है, this is your quantum mechanical model, which is a correct one, right? And this is very important. We will study this in details. Okay.
Do I
So
write
let's
this all?
start. Yeah, you can write. In your own words, you can write. Yeah, so atom, each element is composed of a smallest particle, right? We know that, which is atom. Each element is composed of a smallest particle, which is known as atom. And atom, this name is derived from a Greek word. this name atom is derived from a Greek word atomos, right, which means not to be cut, not to be cut or indivisible, right?
Okay.
Yeah, and one more question comes, like who first coined the term atom? So Democritus. The answer is Democritus. Who coined the term atom? Democritus was a person who first suggested the existence of atom, right? And he also coined the term atomos. Atomos means not to be cut or indivisible particle. Okay, तो ये डेमोक्राइटस का ही कॉन्सेप्ट जे डाल्टन ने ली and he gave a theory which is known as Dalton's theory of atom. Okay.
Okay.
Okay, now here
Can you
comes the
scroll up?
Dalton's.
I'm still writing.
Yeah, just write it down.
Done, ma'am.
Okay, let's move to the Dalton's atomic theory. Yeah, so Dalton's he gave this theory and it is based on the nature of matter, right? And this theory was given by Dalton's in 1808. 1808, remember the date. Okay, now let's see what are the postulates, what he said in the theory. Now, what is postulates? Postulates, what are postulates? It is just an axiom. Axiom type means इसका कोई भी प्रूफ उन्होंने नहीं दिया था, एक्सपेरिमेंटल प्रूफ कुछ भी नहीं था, बट उन्होंने जस्ट अ थ्योरी दी थी एंड वर्ल्ड ऑल द वर्ल्ड started to believe it without any proof, without any experimental proof. We just believe that theory. So that's the hypothesis. It's just a hypothesis, right? So it's
And what is
that's the
hypothesis mean?
hypothesis means इन्होंने बस assume करके उन्होंने theory दे दी, इसका कोई भी proof नहीं है, right? Hypothesis वो होता है जिसका कोई proof नहीं है, just like a axiom. कोई भी experimental proof नहीं है, कोई भी इन्होंने particular experiment नहीं किया, उसके basis पे ये नहीं था, it's just a theory, right?
Okay.
So according to, so he gave 5 postulates. So there are 5 postulates in Dalton's theory. First point is this. He said that all matter is made up of tiny indivisible particles called atom, right? He said that atoms is a tiny indivisible particles, mean we can't divide the particle atoms. Okay, atoms are not to be cut. Second point is that further जब electrons की discovery हुई by J.J. Thomson, then this theory, this point proved wrong, right? Means the atoms, J.J. Thomson proved that atoms have subatomic particles, which is electron, right?
Yeah.
Second point was that all the atoms of a specific elements are identical in mass, size, and other properties, right? He said that all atoms of a specific elements, for some specific, when we talk about some specific element, particular element, then they are identically in mass, size, and other properties, right? And when we talk about the atoms of different elements, so they exhibit different properties and vary in mass and size. Okay, so but he didn't tell about the isotope and isobar. See, isotopes. Isotopes are those substances which have atomic number same but atomic mass different, right? Atomic
Yeah.
mass is different. But what he said that all atoms of specific elements are identical in mass, size, and other properties. But here in isotope, we can see that atomic masses are different. Atomic number is same, but atomic mass is different. But he didn't give the concept of isotope and isobar, right? Now, what is isobar,
Yeah.
Aisha?
I don't know.
Don't know? What is
No.
isobar? Just opposite to that of isotope. Isotope is similar atomic number but different atomic mass, right? But isobar is atomic mass is same but atomic number is different, right? Atomic
So
number is
they
different.
will be different elements, right?
Yeah, different elements होंगे but उसके atomic number different होंगे but atomic mass same हो, right?
Oh,
Atomic
okay.
mass will be same. That's the isobar. Okay, don't be confused in those two, isotope and isobar. Okay, next is your atoms can neither be created nor be destroyed. Okay, he said, means the law of conservation of mass. He just talked about the law of conservation of mass. Atoms can neither be created nor be destroyed. Okay. Fourth point was that atoms of different elements can combine with each other in fixed whole number ratio in order to form compounds, right? Mean the definite proportion. Okay, law of definite proportion जो हमने first unit में पढ़ा था. So atoms of
Yeah.
different elements can combine with each other in fixed ratio. He said that in a fixed ratio in order to form compound, right? In a fixed and simple whole number, fixed simple whole number ratio you can write. Okay. But in the case of like glucose, C6H12O6 or sucrose, C11H22O11, like when we talk about the complex molecules की जब हम बात करेंगे तो you can see this is not a simplest whole number ratio. You can't simplify these, right? Means you can't write C just like C1. जब आप इसका simplest form लिखोगे तो you will divide all the terms by 6, right? So it will give you
Yeah.
CH6, CH6O, right? CH2.
H2O.
Yeah,
That will be the
CH2O.
empirical formula, right?
Yeah, but we can't write it like this, right? We can't write it like this for the complex molecules like glucose, sucrose, and other complex constituents, right? So again, these postulates become wrong, right? Because he said that atoms of different elements can combine with each other in a fixed simple whole number ratio, but this is not a simple whole number ratio, right? So
Yeah.
this point also proves wrong. Next postulate was that atoms can be rearranged, combined, or separated in a chemical reaction, which is okay, right? When some chemical reaction occur, then atoms are rearranged. Atoms rearrange themselves, combine themselves with other, or separated from each other to give a product, right? Which happens in a chemical reaction. So this was these are the 5 postulates of Dalton's theory. I hope it is clear now.
So only one of them was correct.
Yeah. One of them, and yeah, he just talked about the law of conservation of mass, law of definite proportion, right? Law of multiple proportion. So these 3 was wrong. This 3 was okay, right?
Yeah.
So he just talked about this. So you can write down the merit if they ask the merit of Dalton's theory. So you can write down these 2 points.
What does merit mean?
Merit means इसके जो merit you can say the advantage or you can say the positive points जो थे Dalton's theory के जो correct point
So,
थे you can yeah.
तो कौन से हैं वो दोनों?
So it
Uh,
was this
fifth.
the atoms of different elements. No,
Oh.
he follows the law of conservation of mass. law of conservation of law of definite proportion means constant proportion and multiple proportion. He just follows these three laws. Okay, and see, we will discuss it. I will, yeah, I have mentioned over here the merits of Dalton's atomic theory, right? So first merit was the law of multiple proportion, the law of conservation of mass, and the law of constant proportions are not violated. He did not violated these law. He just followed these law in his theory, right? And second merit was that the theory provides a basis to differentiate between elements and compounds, right? He, according to the theory, you can differentiate between elements and compounds. Okay,
Okay.
so you can write down the merits. Mainly, sometimes they ask the limitations of Dalton's theory. Limitation and postulates are very important. Okay. इस क्लास
Okay.
में भी आपका 11th में भी एंड फर्दर आप जब भी जाओगे इंटरव्यू के लिए तो दे कैन आस्क यू व्हाट आर द लिमिटेशंस ऑफ डाल्टन्स थ्योरी so just like a story you can remember this clear have you written the
Okay.
postulates all the postulates
No,
have
ma'am.
you written okay just write it down done
Almost, ma'am. Done, ma'am.
so now write down the merits first then I will explain the limitations
only these two, right?
Yeah.
Done, mom.
Now see, these are the limitations, means the drawbacks, जो कमी रह गई थी डाल्टन्स की थ्योरी में, right? So first, you can see that it doesn't account for subatomic particles. Okay, he just said that the atoms are indivisible. You can't divide the atoms in different particles, right? But further, when J.J. Thomson just discovered the electron, then this theory, this point proved wrong. So it doesn't account for the subatomic particles. This is the first limitation, right? Second limitation was that it doesn't account for the isotopes, right? He said that, now see the second point. He said that atoms of a specific elements are identical in mass, right? But it is possible for for an atom that its atomic mass is different, right? Its atomic mass is different, atomic number is same in the case of isotope, right? Similarly, he doesn't account for the isobars also, means isobar also exist, means the same atomic atomic mass but different atomic number, right? It also exists, but उन्होंने डाल्टन्स ने ऐसा कुछ नहीं कहा था. He said that see the second point, that atoms of different element exhibit different properties, right? And vary in mass and size. He said that vary in mass means the mass will be different, but here in the case of isobar you can see the mass is same. Okay, let's see some example, like when we talk about the isotopes of hydrogen, just a second, I'm writing H1, this is hydrogen, this is H1 and 2, this is deuterium, and this is tritium, right? So this is the isotopes of hydrogen, means isotope, you can see the atomic number is same for all the these isotopes, but the atomic mass is different, right? For hydrogen it is one mass. When we talk about the deuterium, right, deuterium, then the atomic mass is 2, and when we talk about the tritium, right, so it will be, the atomic mass will be 3. Okay, so this is the isotopes of hydrogen. Clear?
Okay.
Atomic number is same, but you can see atomic mass is different, 1, 2, and 3. And this is in the case of deuterium. This is known as deuterium, right? And this H1 and 3, it is known as tritium. And this is simply known as hydrogen. Okay, so these are the isotopes of hydrogen. Clear? Similarly, isobar. So isobar means atomic number is different, but atomic mass is same, right? So you can see argon, for example, argon and calcium. Now tell me the atomic number of argon. मैंने आपको याद करने को बोला था, till 30.
Yeah.
Okay, tell me the atomic number of argon. Argon and calcium, what is the atomic number?
I'll count 1 minute. 5. Is it 17?
No, it's 18. 18 for argon and 20 for calcium, right? Now you can see that atomic number is different, right? But atomic mass is same. Atomic mass is argon, for argon it is 40 and 40, right? So this is the isobar, example of isobar. I'm writing over
Oh,
here. Argon 18 and the atomic mass is 14. And calcium 20 and it's 40, right? So you can see that these are the isotopes. Isobar, sorry. This is the isobar. Means atomic mass is same, mass number is same, but atomic number is different, right? तो उन्होंने डाल्टन्स ने
okay.
ऐसा कुछ नहीं बोला था कि एटॉमिक मास, एटॉमिक आइसोटोप एंड आइसोबार भी एग्जिस्ट करते हैं, राइट? सो दिस इज द लिमिटेशन. Fourth limitation was that elements, he said that elements need not combine in simple whole number ratio to form compounds, right? He said that in his postulates that elements combine with each other in a fixed simple whole number ratio in order to form compounds, right? But I already just explained it to you, like in the case of, for example, like complex molecules, they did not combine in a simple whole number ratio. Like glucose C6H12O6 is not a simple whole number ratio, right? And when we talk about the sucrose C11H22O11, so this is again not a simple whole number ratio. Okay, so elements, it is not necessary for an element to combine in a simple whole number ratio to form a compound. Okay, so this is a limitation of Dalton's theory, because he said elements जो होंगे वो सिर्फ simple whole number ratio में ही combine कर सकते हैं compound form करने के लिए. But there are some exceptions, like जो complex molecules होते हैं, certain complex organic molecules होते हैं, they combine in a not in a simple whole number ratio, right? So this is a fourth limitation.
Yeah.
Fifth limitation was that this theory doesn't account for allotropes. Now you will tell me what is allotrope. Do you know?
Allotropes are
Hmm?
the same element, but then I think they have their atomic mass or atomic number different.
No, no. Allotropes is for the same different. See, for example, carbon and graphite. These are allotropes of carbon, right? Means same element के ही बने, right? Carbon ही दोनों में present है, but they have different properties. They have different chemical and physical properties. So that's the allotropes, right? They are
Oh,
of same element. They are formed from a same element, but they have different physical and chemical properties. That's the allotropes. Okay, so Dalton's, he did not give the account for allotropes. Okay, so you can write down. These are the limitations of Dalton's atomic theory. So he didn't tell why the chemical properties of carbon and graphite are different, right? Because दोनों में ही carbon present है, दोनों ही carbon से बना है, but why their properties are different? Okay, ये explain नहीं कर पाए थे Dalton. So that's the limitation. Okay. Each and every point clear or not?
yes, ma'am.
Okay, now
So
you can write down. Yeah.
isotopes have different mass. Isobars have different atomic number, and
Yeah.
allotropes have different properties.
Yeah. Very good. Okay, तो ये terms आपको याद होने चाहिए. In Viva also sometimes the externals ये basic ही questions पूछते हैं आपसे, ज़्यादा tough conceptual questions नहीं पूछेंगे. They ask this basic terms.
मैम किस चीज का Viva?
Practicals and all. Practicals में Viva नहीं होते हैं आपके?
We have Vivas.
Yeah. Practicals. In 12th standard, not in 11th. In the further
Oh,
class, in the future, I am just telling you.
oh,
Because from 9 to 12, these are some basic chapters, basic classes. आपके basics अगर strong होंगे, then you will crack any interview and any competitive exam. Okay. Just write it. And
yeah.
then we will start the main experiment, which is cathode ray experiment. How the fundamental particles are discovered, we will get to know one by one. Like when we will just discuss about the electron discovery, proton discovery, neutron discovery. It's very interesting experiment. Just like history, जैसे आप history में पढ़ते हो ना, ये हुआ पहले, then ये हुआ, तो just like that, this chapter is.
Done now. Mom, are you saying something because you're muted? I can't hear you. Mom, I cannot hear you. I'll try to leave and come back. I still can't hear you, Mom. Mom, I can't hear you.
Now check. Am I audible?
Yeah, Mom, now you're audible.
Oh, I think it's mic fault.
Oh.
Just a second. I'm sharing my screen. Okay, screen visible?
Yes, Mom.
Okay, now see. So we will see one by one what is the discovery of electron, proton, and neutron, right? So electron, first we will study about the cathode ray experiment, right? Which leads to the discovery of electron. Due to this cathode ray experiment,
Can't hear you again.
now check. Am I audible, Aisha?
Yeah, Mom, now you're audible.
So, who discovered the electron?
J.J. Thomson.
Discovered electron, right, in 1897. Right? And we know that electron is a negatively charged particle. Now see what is that experiment. So let's see the setup first. What he did in this experiment. So this is a cathode ray experiment in which he just take this glass containing. This is a cathode ray tube. Right. This tube is known as cathode ray tube. Right. Tube, you
Okay.
can see that this is a glass. The cathode ray tube is made up of glass containing two thin pieces of metals. You can see here it is a metallic body, and here it is a metal. Right. So these are two electrodes. He used two
Is it a
electrodes. Yeah.
is it a specific metal or any metal?
He used any metal. It's not depending on the type of metal he used. Right.
Okay.
Yeah, in this experiment, it doesn't depend on the material we used in the to make this electrodes. So this is the electrode which is negatively. You know that cathode is cathode is negatively charged, right? Negative electrode, and anode is positive electrode, right? So you should remember that cathode is always negative and anode is positive. Okay, you can use that trick also. Anion, right? An ion, which means in negative ion. And negative ion is always negative. An ion is negative, right? And cation was positive, right? So it's just opposite
Yeah.
to that of anion and cation. Anion is negative, but anode is positive. Cation is positive, but the cathode is negative. Just remember that, right? So what
Okay.
he did, he take this cathode tube, which is made up of a glass containing body, this is a glass containing body, and here at both the terminal, here attached are two pieces of metals. okay, which are known as electrodes. Here it is cathode, which is negatively charged, and here anode. Okay, and the condition of this experiment was low pressure. He used low pressure and a very high voltage. Right? We used high voltage. Right? At this condition, at these two conditions, means low pressure and very high voltage, electrical discharge through the gases could be observed only. Right? He just used these conditions to see the electrical discharge through the gases. Right? What he first, he just take this glass containing tube, which is known as cathode ray discharge tube. Right? This is known as cathode ray discharge tube.
Okay.
Here he just attached two electrodes, which is cathode over here and anode over here, right? And we just यहाँ see यहाँ पे एक evacuate वैक्यूम पंप लगा है. यहाँ से क्या किया उन्होंने, सारे जो गैसेस हैं उसे पार्शियली इवैक्यूएट कर दिया, राइट? इसके अंदर जो कैथोड रे डिस्चार्ज ट्यूब के अंदर जो भी गैसेस है उसको पार्शियली इवैक्यूएट कर दिया, राइट? पार्शियली इवैक्यूएटेड, बट here also some gases are present. It means partially evacuate किया, fully evacuate नहीं किया उन्होंने. Clear? Now what he did, he just passed this high voltage. High voltage was approx 10,000 volt. He just passed 10,000 volt. Okay. So when the high voltage 10,000 volt is applied across these two electrodes, what happens? The current starts to flow. The current starts to flow, and the beam of particles, you can see over here, the beam of particles are were moving from the cathode to the anode, right? Cathode to the anode. So these were called cathode ray. Why these are called cathode ray? Because ये cathode ray से ये rays आ रही है. Cathode से की तरफ से rays आ रही है और anode की तरफ आ रही है. That's why they are known as cathode ray, right? But these are invisible. But these rays were invisible. How he could observe these rays? So here at the anode, he just perforate this anode. यहाँ पे anode के पास उन्होंने perforate कर दी. Perforate means small उसमें holes कर दी. Right? Anode में उन्होंने small holes कर दिए. And behind the anode, he just coated this glass wall by zinc sulfide. Now, why zinc sulfide? Here is a question: why he use zinc sulfide? Because see, zinc sulfide is a material which has a fluorescence property. It has a fluorescence property. Means fluorescence property means it will show bright spot, bright light. जब भी इससे कोई भी रेस टकराएगी, right? जब भी जिंक सल्फाइड से कोई भी रेस टकराएगी तो it will just bright light वो show करेगा, right? Bright spot show करेगा. So it will be observable by the metadiodes. Clear? So fluorescence or phosphorescence, it is the ability of certain chemicals, right? It is the ability of a certain chemicals to give off visible light, right? जो light, जो आपकी rays जो visible नहीं है, उसे visible करके वो show करता है. So these are some properties of some chemicals, which is तो उन्होंने zinc sulfide use किया because zinc sulfide is a phosphorescent material, right? A phosphorescent material means when some rays strike to it, just hit this zinc sulfide. This zinc sulfide will show a bright color spot, a bright light. Okay, and bright light यहाँ पे shine करेगा तो वो easily observable होगा. So we can see that जो J.J. Thomson ने ये देखा कि यहाँ पे जब rays आ रही हैं, obviously rays इस side से आ रही होगी towards anode. तभी यहाँ पे perforated उन्होंने किया था. Anode में क्या किया था उन्होंने? छोटे छोटे होल्स कर रखे थे, परफोरेट कर दिया था. एंड इसके बैक साइड में यहाँ पे ग्लास वॉल थी, इस पे जिंक सल्फाइड की कोटिंग कर दी थी, राइट? जो भी रेज आ रही थी ये परफोरेटेड एनोड के से अंदर ये जा रही थी और यहाँ पे वॉल पे स्ट्राइक कर रही थी, राइट? तो जब ये स्ट्राइक कर रही थी यहाँ पे ब्राइट कलर की लाइट शो हो रही थी. So due to that light, उन्होंने ये conclude किया J.J. Thomson ने कि there is a certain ray which is coming from the cathode towards the anode, right? And because cathode से आ रही है, तो and anode is positively charged and cathode is negatively charged. So there must be this charge is must be a negatively charged. That's why it is attracting towards the positive charge, right? Because we know that opposite charge attract each other, right? Opposite charges attract each other. So ये अगर नेगेटिवली चार्ज बॉडी से आ रही है तो ऑब्वियसली ये यहाँ से नेगेटिवली चार्ज होगी, तभी तो ये पॉजिटिव की तरफ आ रही है, ऑपोजिट चार्ज को अट्रैक्ट कर रही है. तो दीज रेज आर पॉजिटिवली चार्ज, उन्होंने ये कंक्लूड किया, राइट? आई होप इट इज क्लियर. ये एक सेटअप समझ आया?
Ma'am, so anodes was also discovered at the same time, or was
No.
that discovered
नो
before?
नो, उन्होंने बस ये कैथोड रे को उन्होंने देखा, बट उन्होंने ये नहीं देखा कि एनोड की तरफ से भी कुछ आ रही है, क्योंकि उन्होंने यहाँ पे कुछ परफोरेट नहीं किया था. अगर उन्होंने कैथोड में भी परफोरेट कर रखा होता और यहाँ पे भी जिंक सल्फाइड की कोटिंग कर दी होती, तब उन्हें दिखता कि एनोड की तरफ से भी कोई रेज आ रही, राइट? बट उन्होंने एनोड यहाँ पे सिर्फ परफोरेट किया था और यहाँ पे कोटिंग की, राइट? तो उन्होंने ये मिस कर दिया था, नहीं तो उस टाइम प्रोटॉन की भी उन्होंने डिस्कवरी कर ली. क्लियर?
Okay, ma'am.
सेटअप समझ आया, एक्सपेरिमेंट समझ आए,
Yes, ma'am. समझा.
right? So this is very important. What I said, I'm just repeating. He just take the cathode ray discharged, and here two electrodes were fixed over here, right? One is cathode and one is anode. And when the high voltage is applied, which is 10,000 volt across these two electrodes, current starts flow. It starts to flow, right? And the beam of particles move in the tube from negative electrode, which is cathode, to the positive electrode, right, which is anode over here. But these particles are invisible particles, right? So how J.J. Thomson could observe that? So he just perforate this anode. Perforate, he just make holes in this anode, right? And he just behind this anode, he just coated it with the phosphorescent material, which is zinc sulfide, right? So when these rays, after passing through anode, this strike zinc sulfide material, a bright spot is developed over here, right? A bright spot is developed on the coating. So he just observed that there is something which is coming from the cathode towards this anode, right? Clear or not? Aisha, clear or not?
Sorry, ma'am, I was muted. I didn't realize. Yeah, it is clear.
Okay, now here are some conclusion which is drawn by the J.J. Thomson using this experiment. Okay, so these are the conclusions of results. Conclusion of the, you can see conclusion of experiment, of this experiment, right? So first conclusion he just observe is cathode ray start flowing from cathode and move towards the anode, right? We just observe that by doing the experiment that cathode rays start flowing from the cathode and towards the anode. Okay. Second, he just observed that these rays are not visible by the naked eye. Okay, but their behavior can be observed with the help of certain kind of material, which is fluorescent material or phosphorescent material, right? So what are phosphorescent or fluorescent material? These are the materials which glow when heated by some rays, right? So he just observed that the rays are invisible.
Yes, ma'am.
Yeah. In the absence of electric or magnetic field, these rays travel in a straight line. Now when when in the same experiment, when he just give the electric fields, when he just give the electric field, what it will this ray which is moving in the straight line, it just shows reflection, right? See, अगर यहाँ पे इलेक्ट्रिक फील्ड उन्होंने लगाया, इलेक्ट्रिसिटी प्रोवाइड की, तो ये क्या हुआ, यहाँ पे डिफ्लेक्शन शो किया, ये जो रेज आ रही थी बिकॉज ये नेगेटिवली चार्ज रेज, राइट, नेगेटिव रेज थी, सो दे विल डिफ्लेक्ट टुवर्ड्स द पॉजिटिव साइड। तो यहाँ पे स्ट्रेट जाने के बजाय they show some deflection towards the positive charge. Clear? When
Yeah,
he
ma'am.
when he apply the electric field, but when he apply the magnetic field, means when he put some magnet over here, what he just observe, he observed the same deflection, right? So these rays reflect towards a magnet, reflect towards a magnet. So we conclude that in the absence of electrical or magnetic field, these rays travel in a right. These rays travel in a straight line in the absence of electrical or magnetic. But when the electrical and magnetic field are applied in the same experiment, he just observed the deflection, right? वो जो rays जो straight आ रही थी वो deflect हो रहा है, कुछ angle बना के वो deflect हो जा रहा है. Clear?
Yeah, ma'am.
Fourth conclusion उनका ये था, in the presence of electrical or magnetic field, the behavior of cathode ray are similar to that expected from the negatively charged particles, right? Because negatively charged particles है, so because we know that opposite charges attract each other, right? तो negatively charged
Yeah.
body है, तो वो attract किसकी तरफ होगा, positively charged की तरफ, right? So same जो नेगेटिवली चार्ज पार्टिकल्स का बिहेवियर होता है, सेम वही कैथोड रे का भी बिहेवियर दिखाओ में. ओके, जब उन्होंने इलेक्ट्रिक फील्ड अप्लाई किया, तो उन्हें जो कैथोड रे का जो बिहेवियर दिखा, विच इज सेम टू दैट ऑफ नेगेटिवली चार्ज पार्टिकल्स. जैसे नेगेटिवली
Ma'am,
चार्ज
so
पार्टिकल्स, या
negatively charged particles and positively charged particles, they were discovered that day, but then just electrons and protons were not.
या
Okay.
नेगेटिवली चार्ज पार्टिकल्स एंड, बट उन्होंने एग्जैक्ट नहीं बताया था कि इलेक्ट्रॉन है. नेगेटिवली चार्ज
Yeah.
पार्टिकल्स और पॉजिटिवली चार्ज पार्टिकल्स को पता ही था पहले से, बट एग्जैक्ट उन्होंने नेम नहीं दिया था कि इट इज अ इलेक्ट्रॉन व्हिच इज अ सब एटॉमिक पार्टिकल ऑफ एटम, राइट.
Yeah.
So he said that in the present it behaves just like a negatively charged particle, means cathode, suggesting that cathode ray consists of a negatively charged particles which are known as electrons, right? He just suggest by this experiment, he just suggests that cathode ray consists of negatively charged particles, right, which are known as electrons.
Yeah.
And the characteristics of cathode ray, which is known as, yeah, sometimes some electrons. What is the other name for electron? This is known as cathode ray, right? And anode ray is known as canal rays. Remember that. Electrons are known as cathode ray, right? Because it is just protons, anode ray. Protons, or you can say anode ray or canal ray. Canal ray. Right. These are two other names of anode ray and proton. Okay, fifth point was that the characteristics of cathode ray, which is the electrons, do not depend upon material. Right? जो आपने अभी पूछा था कि अगर वो मेटल, कौन सी मेटल लिया उन्होंने, तो वो कोई भी मेटल ले सकते हो. It doesn't depend upon the material of electrodes and the nature of gas present in the cathode ray tube. Right? It doesn't depend upon the nature of gas present in that cathode ray tube and the material of electrodes. But we just prefer hydrogen gas, right? Scientists.
What property of hydrogen makes it preferable?
Yeah, because it is a lighter. It has many properties, like it is light in weight, it is light gas, right?
Oh.
And because it is a simple atomic structure, it has a very simple atomic structure. It has the ease of ionization. Easily ये ionize हो जाते हैं, right? Easily ionize हो जाते हैं. और ये बहुत ही लाइट गैस होता है. ये सिंपल एटॉमिक स्ट्रक्चर होता है, मींस एटॉमिक नंबर इज 1, एटॉमिक मास इज 1, राइट. तो आप इजीली आप ये, इसीलिए इसे आइडियल गैस लेते हैं, ठीक है. इसलिए हम अदर गैसेस ज्यादा इसे प्रेफर करते हैं, हाइड्रोजन गैस. right?
Okay, ma'am. Yeah.
So thus we can conclude that electrons are a basic constituent of all the atoms. Okay, according to that
Yeah.
experiment, cathode ray experiment, we can conclude that electrons are basic constituent of all the, right. Now see,
Ma'am, what about protons then?
protons we will see now. We
Okay.
will see one by one. Just have some patience. It's very interesting chapter. I know. क्यूरियोसिटी होगी आपको जाने की प्रोटॉन्स कैसे आया न्यूट्रॉन्स कैसे आए right, so we will see one by one each and every experiment. And yeah, this chapter is very long. This chapter is very, it takes very much time to complete this chapter.
Oh.
Yeah, so if you have any doubts like in periodicity chapter, so you can inform me. I will just schedule your extra classes. ओके इफ पॉसिबल अगर आपके एग्जाम्स वगैरह हैं या कुछ भी टेस्ट वगैरह है, अगर कोई भी प्रॉब्लम आ रही है तो वी यू कैन आप हमारी टीम को आप बोल सकते हो, दे विल अरेंज सम एक्स्ट्रा क्लासेस. ओके, इन एक्स्ट्रा क्लासेस वी
Okay.
विल कवर दैट. जो भी आपके टॉपिक्स नहीं होंगे, कोई भी प्रॉब्लम होगा तो इन एक्स्ट्रा क्लासेस वी विल डिस्कस.
Okay.
Okay, now there are some properties of cathode ray. Now see this diagram. So this diagram here, I just explained it to you. See, this is the electrical field. When you apply electrical field, when the J.J. Thomson applied electrical field, what he just observed, he observed the deflection. Right? See this from here. This is the straight line, right? But when he applied the electrical field, here some these rays, this cathode ray, it shows some deflection. It deflects towards this. Okay. Because see cathode ray is negatively charged and ये पॉजिटिव की तरफ अट्रैक्ट है बिकॉज ये नेगेटिवली चार्ज बॉडी की तरफ एक्ट कर रही है, बिहेव कर रहा है. तो ये क्या होगा, पॉजिटिवली चार्ज बॉडी की तरफ, ये पॉजिटिव चार्ज है, ये प्लस एंड माइनस, तो पॉजिटिव टर्मिनल की तरफ ये डिफ्लेक्ट हो जाएगा. अगर ये कैथोड रे अगर नेगेटिवली चार्ज होता तो इट विल डिफ्लेक्ट टुवर्ड्स दिस, टुवर्ड्स द नेगेटिव टर्मिनल, टुवर्ड्स लाइक दिस. Okay, and this is the phosphorescent screen, which is made from zinc sulfide. Right? Phosphorescent screen laga, that's why the J.J. Thomson observed that spot, that bright spot. Clear or not?
Yeah.
Okay. So write down the properties of cathode ray.
No, I didn't write the I didn't write from the experiment.
Okay, you can write.
I'll take a screenshot.
Yeah, you can take because only 5 minutes are left.
Can you scroll up?
After the
Done
class,
now.
please just go through this. ओके, बिकॉज अभी नहीं पढ़ोगे
Yeah.
आप तो भूल जाओगे. अभी आप पढ़ लोगे, रिवाइज कर लेना एक बार, एंड देन ट्राई टू राइट इट बाय योरसेल्फ. Each and every point, try to write it by yourself. What are the conclusions? Just like a story. Okay.
Yeah, I'm okay. Done, mom. I took a screenshot.
From the properties. The first property of cathode ray was cathode ray travel in a straight line. Cathode ray travel in a straight line. Right. Second property was when a cathode rays produce mechanical effect. It produce mechanical effect. As they can rotate the wheel placed in the path. They can So when J.J. Thomson just placed a wheel in the path of the cathode ray, he just observed that it just rotates that wheel. Means it shows some mechanical effect, right? So a mechanical effect is the properties of cathode ray. Yeah. Next property of cathode ray is that cathode rays consist of negatively charged particles. Charged particles, which is known as electrons. Okay. Fourth properties of cathode ray is that cathode ray travel with high speed. Travel with high speed. Fifth property was that cathode ray can cause fluorescence. Can cause fluorescence. Sixth property was that cathode ray heat the object. Heat the object on which they fall. They fall. Why? Why cathode ray heat the object? Due to the transfer of kinetic energy, right? Of the object. Seventh property was that when cathode ray fall on solids, okay, when cathode ray fall on solids such as copper or X-rays, right? So X-rays are produced whenever the copper rays, cathode ray fall on solids. So they produce X-rays. And write down. And yeah, one more property is this cathode ray possess ionizing power. Right. So cathode ray possesses ionizing power. So what is ionizing power? Means whenever the gas is passed, right? Whenever the gas is passed, so they ionize the gas through which they pass. And you can write down cathode ray possesses ionizing power. Means they ionize the gas. They ionize the gas through which they pass. Through which they pass.
Okay.
For
And
example,
that's
is discharge tube में for example HCl रहा होगा, right? For example HCl रहा होगा, तो cathode ray जब भी cathode ray वो flow होगा, तो it will ionize the HCl, means H plus and HCl minus में ionize कर देगा, okay, ions में break कर देगा, so that's the property, okay. Ninth property is that they can penetrate through metallic sheets. right? They can also penetrate through thin metallic sheet. Next, you can write down the nature of these rays doesn't depend upon the nature of gas or the cathode material used in the discharge tube.
Same as the anode rays.
Written, so these are the properties of cathode ray. These cathode rays, we can conclude that these cathode rays are the stream of electrons